In section 1.1, we're going to learn about variables and expressions. So to start, a quantity is anything that can be measured or counted. In algebra, we usually use symbols to represent quantities that are unknown or may vary. A variable is a symbol, usually a letter, that represents an unknown value or quantity. And finally, an algebraic expression is a mathematical phrase that includes one or more variables. So in our first exercise, we're going to look at a word phrase and then model what that phrase is showing, and then finally write an algebraic expression for that phrase. The first one we'll look at is x more than 32. So to model that, we have the number 32 and we're going to add some number x to it. So in algebra, how we would express that is we would write 32 plus x. The next one that we'll look at is n times 8. So that means that I'm going to write n 8 times. And in algebra, we'll represent that with multiplication, 8 times n, or 8n. Normally, if we use multiplication, we don't have to put the multiplication sign down. So let's remember some key words will help us know what to use. So whenever you see the word sum, more than, that always means to add. Whenever you see difference or less than, that's always going to mean to subtract. Times, product of, multiply, and finally quotient or divided by would mean to divide. So now let's look at some trickier word phrases. Again, we're going to look for those key words to write an algebraic expression. 3 more than twice the number x. So 3 plus 2x. More than means I'm going to add 3, twice the number x, 2 times x. The next expression, 9 less than the quotient of 6 and a number x. So I'm going to be subtracting 9 because I see less than and 9. And then the quotient of 6 and a number x. So quotient of means I'm going to do 6 divided by x. And finally, the product of 4 and the sum of a number x and 7 would be represented like this. So I'm going to do 4 times and then the sum of x and 7. So since I want to add x and 7 first, I'm going to put those in parentheses and then times that whole thing by 4. Finally, the whole reason why we do this is to kind of represent these real world situations. So we're going to end the video with this problem. John decides to buy a YMCA membership. There is a $55 registration fee and a $30 monthly membership fee. So I want to write an expression to show how much money John will pay to the YMCA after X months of being a member. So looking at this, we're going to start with that $55 registration fee. When he walks into the Y, he's going to pay that $55. After that, we're going to add that monthly fee every month that he stays a member. So I'm going to be adding on, so I'm going to do plus 30, and I'm going to write 30x because I'm going to do 30 times however many months he's a member. So if he's only a member for 1 month, it would be 55 plus 30 times 1, so $85. If he stays another month as a member, it would be plus 30 again, so 55 plus 30 times 2, so on and so forth. So since the months, like the length of time that he's a member is our unknown quantity, that's why we have an x there. So finally, that expression, 55 plus 30x, would represent how much money John's going to spend to the Y after being a member for X months.